when we solve a circuit with a switch in it, okay? And so we have this circuit with a switch. I want to put a marker here. I'm going to call this marker I2. And I'm going to say I2 in the open position, I2 is equal to 3 amps. Okay? I2 is equal to 3 amps. Yes?
For the open position, is open just like that?
It means the switch is open, right? There's no connection here, so current doesn't flow that way. That's what a switch does, is it interrupts the current flow. Okay, so I will have no current flowing that way. All right, so there's the circuit presented to you with the givens. So what I want you to do is go ahead and draw your voltage and current arrows, okay? Go ahead and draw your voltage and current arrows. And put in, well, I'll wait till you're done. We can put in the given in a moment. Doing that, I'll hand back some stuff. Preston, here's your test correction. They're supposed to be due tomorrow, but you missed so much that I'll take them when you can get it to me, okay? Oh, Connor. There's Connor. Alexander. Edison. Evan. Okay. All right. So everybody has their current voltage arrows drawn exactly like mine. Is there anybody that has anything different than mine? So everybody agrees that this is what you have on your paper, yes? You're all wrong then. And I'll explain in a minute.
Should the potential arrows be going on the bottom resistors, be going the other direction?
No, those arrows are drawn correctly. I'll show you how you're wrong. These arrows, the pink arrows, are done fine. There's something you're missing though. And that's fine. We'll learn about it, okay? We'll learn what we got. Okay. So let's go ahead and put in the given of I2 being 3 amps. So if I2 is 3 amps, what's this right here? 3 amps, isn't it? Okay, so there's 3 amps right there. Okay, so now I've put in my givens. Now I want to calculate the total resistance. Okay, so since I have a switch, what I got to do is I got to look at this and go, what's my circuit really? Okay, so if I look at this, there's no current that's allowed to flow across this switch in the open position, right? So that means what's my current here and what's my current here? 0, isn't it? So I could write in there 0 amps, 0 amps. Now, what's my voltage? What is it? 0 volts, 0 volts. Make sense? Since I have no current flowing, the potential drop across the resistor is 0. Make sense? Okay. So now I look at this and I go, okay, what kind of circuit do I have? And so with an open switch, since these resistors are in series with the switch and there's no current going across the switch, that means that nothing's happening in this side of the circuit. So I can ignore it. So I put my hand over it and I ignore it and I see that what do I have right here? I just have a series circuit, don't I? And so there's 2 resistors in that series circuit. There's the 2 ohm and the 4 ohm. And so what I can do is calculate RT is 2 ohm plus 4 ohm equals 6 ohms. So there's my total resistance RT, okay? Good. So now I've calculated RT. Now, with a circuit like this, I wouldn't draw a equivalent circuit. I really don't need it in this one, okay? So I'm not going to draw it. It's just one resistor in a battery. So I'm not going to pay too much attention to it. Okay, so now I know that I'm done with this. So now I can start calculating. So I use V equals IR, KVL, or KCL. So do I know 2 of 3 things anywhere? I do, right? And I know 2 of 3 things here. So 2 times 3 is 6 volts using V equals IR. Now, because the 2 ohm and 4 ohm are in series, what can I say about the current in the 4 ohm? It's also what? 3 amps, right? This is 3 amps because of that being 3 amps. Now I know 2 of 3 there. I can calculate the voltage. 3 times 4 is 12 volts. Okay, now if I put A here, and B here, and C here, and D here, okay? I need to get what's at the battery, and then I'll be done, won't I? Okay? So if do I know a path from A to B where I know all of the voltages? I do. I go up 12 and up 6. So A to B is how many volts? 18. So A to B has to be 18. This is 18 volts. Okay? Good. Now, I know there's 3 amps of current here. 3 amps goes into the bottom of the battery. How many has to come out the top? 3. So I have 3 amps there. So 18 divided by 3 is 6 ohms. My RT makes sense. Everything looks good. Right? Everything looks fine. Okay? So let's take a look at just making sure everything is fine. I go from C to D. C to D. How many volts do I go up? 6 volts. Correct? Okay, I go this way, C to D. I'm going against the 12, so I go down 12, right? And then I go through the battery, up 12 to D. That's how many volts? Down 12, up 18, 6. So it checks there. Okay, so 6 volts checks. Now, I go C to D this way. I go up 0, and I'm at 0. Is KVL bad? Or did I forget something? What has to happen at the switch? I have to account for the voltage rise. Instead of going up a little bit here, like I start low and going up 3 volts and then up another 3 volts to 6, what's happened is I take those out and I go all the way up to the switch and then I jump 6 volts right at the switch. So I have a voltage arrow at the open switch that is 6 volts, and I got that by KVL. KVL has to be satisfied even across a switch. Okay, and that's exactly what happens over here. If I go to the light switch, right now, the light switch is just letting electricity pass through it. It's acting as a wire. And so all the lights are on. When I turn it off, I have no current flowing through the wires now. And so since there's no current flowing through the wires, I have no voltage drop. Where did my voltage drop go? Well, if I took a voltmeter and I measured from one side of the switch to the other side of the switch, I would measure 120 volts. If I turn it on and I measure from one side of the switch to the other side of the switch, I would see 0 volts. Okay? So when it's closed, it acts like a wire. I have no potential drop across it. There's no resistance in the switch. Okay? Does that make sense? And then when it's open, that's where all the voltage drop is. Okay? So you see, C to D has to be 6 volts. So in order to satisfy KVL, this has to be 6 volts in an open switch. Make sense? Okay? All right. So now everything is fine. So could I ask my boss, or tell my boss whatever they need to know? Right, then go to lunch. Okay, good. All right, so everything's there. Are there any questions on that? So in an open switch, you need to make sure that you have a voltage arrow on the switch. Okay, if they ask you a circuit question on the AP exam, for sure, if there is a switch on, for sure, they're gonna wanna see a voltage arrow. They'll ask you some kind of trick question to see if you really understand that the voltage rise is across the switch. Got it? Okay, good. So any questions, any other questions on that? Okay, now, since it's open, that's great, but now we have to analyze it closed. So we gotta do a whole new circuit. So I have to rewrite the entire circuit. But before I do that, I need to know what I can bring over from here to my new circuit. Now, resistors don't change. So resistors remain the same. So I can bring every resistor over into my new drawing, the value of the resistor. Okay, I can bring over the value of the resistor. The other thing that doesn't change is a battery. Because doesn't the battery voltage, isn't that what the purpose of the battery is to maintain a constant potential difference? So if it's 18 volts when the switch is open, when I close the switch, it's still going to be 18 volts. So the V battery remains the same. V bat remains the same. Everything else goes away. You have to reanalyze the voltages and currents in each of the resistors. Okay, and the current coming out of the battery. Okay, so the only thing I can carry over is V bat, this 18 volts. Everything else needs to go. So go ahead and redraw your circuit. I'll do mine teacher stuff. Okay, but what we're going to do now is we're going to have a closed switch. So this thing here now acts as a wire. It acts as a wire. Okay, so a closed switch acts as a wire. And all I do is ignore it. When I have a closed switch, I just ignore it and analyze my circuit like I know how. RT goes away, and anything else goes away. So all I'm left with is this now. Okay, but now I don't, because I have a wire, there's no potential drop across the switch. It acts like a wire. Okay, so everybody got it written down? Close to it? Okay, good. So now what I have to do is I have my voltage and current arrows done. Okay? I put in my label is given, right? This no longer is true because it's a current, so I have to get rid of it. And a voltage, add a resistor. So I get rid of everything about a resistor. The only thing I keep is the battery voltage, and so I brought that over as a given. Now I have to calculate RT. Okay? This is not an easy circuit. Okay, so what I have to do is identify the type of circuit it is. So what kind of circuit is this? Parallel circuit. So that means that when I pull out the 4 ohm resistor right here, there's an alternate path for the current to flow. Is that correct? Is that what you're telling me?
No.
So if I pull this resistor out, it doesn't shut down the circuit.
No.
It does? Isn't that the definition of a series circuit?
It's a parallel series.
Isn't that the definition of a series? So it's not parallel. Is it? That must mean that it is series, right? So that if I pull out this 2 ohm resistor, there's no way for the circuit to run. Wait, there is.